Hey gang, Mr. Rising back here again, hopefully a little smoother this time. This is section 1.2, all about constructing and measuring segments. We're going to do some work in class with compasses, so don't worry about that part of it now, but you do need to get the basic idea of what segments are and how to measure them. One thing that comes to mind all the time is when you deal with a midpoint, or the idea of midway. So what is midway between Seward and Homer, as the crow flies? Well, that's a really good question. If we made a line from Seward, or a line segment, from Seward to Homer, you'd then say, well, where's midway? And of course, that would be the midpoint. So that's going to be part of our conversation today, looking at segments and segment midpoints. Again, last time we talked about postulates or axioms. So that is a rule that is accepted without proof. I am not a Martian, postulate about me. But a rule that can be proved is called a theorem. And we deal a lot with theorems in geometry, and we deal with logic, and that's what we're going to be talking about here. We're going to start working on theorems, and how to prove them will be, we'll start that more in chapter 2. So a ruler, you're all familiar with rulers, but we need to just define something to make it clear. It's used to measure distances between points, and each of these points is assigned a coordinate. So the following postulate is in your book, talks about rulers. So the points on a line can be put into a one-to-one correspondence with real numbers. Right? So that means we can physically measure something. We can take a tool and measure something and give someone else the same tool. They'll come up with the same measurement. Please put this postulate in the postulate section of your notes. So, how to use a ruler. I'm sure all of you are familiar, but let's just go through it one more time. Place the ruler against the segment, like that. Read the coordinate of S. The coordinate of S, where I put the ruler here, would be 0. Read the coordinate of M. On this one, it would be, let's call it 3, and it's a little more than 3/4. It's almost 3 7/8. And this will change depending on the scale or the type of ruler. So this is inches. Generally, we're going to use centimeters, meters. We're going to use metrics because it's the standard form. Subtract the two values. So 3 7/8 minus 0 is 3 7/8. So the length here is 3 7/8. How we say that in geometry, when I write SM without the mark on top, then I'm referring to the distance. So in this example here, SM, I'm not referring to the segment itself, I'm referring to the length of the segment according to its measurement. And in this case, the measurement in inches. Right, would be 3 7/8 inches. And again, a segment is one dimension, right? So inches is just leaving it, and inches is fine. All right, so try this one. See if you can figure out what the length is to the nearest tenth of a centimeter. Okay, very good. You tried it. So you said the coordinate of S is 4. The coordinate of T is 7.5. We'll use decimal for this one just to keep you on your toes. So if I subtract 4 from 7.5, of course, I get 3.5. And that would be centimeters. The same thing is true, of course, if I shifted this over. Let's see if I can just do it. Look at that. The magic of computers. And it just jumps out at you right away. So when you can measure something starting on the edge, it makes your math a little easier because it's just that number. But even if you can't, wherever I put this, the length of that segment is still going to be 3.5 centimeters. And this is what we just talked about. So the distance between any 2 points is the absolute value of the difference between those coordinates. And whether you start with coordinate A and subtract B, or you do B and A. Now, just note this. the coordinate of point A, so this refers to point A. This is the value on the ruler that goes with A. This is the coordinate of B, saying, oh, I'm sorry, this is point B. This is the coordinate, the value of B. And so when we say AB with a little segment bar over it, that means we refer to segment AB. When we say capital letter A, capital letter B, now we're talking about the length between the two. So go ahead and try these problems right now. Pause it and see what you get. All right, very good. When I look at BC, I'm talking about this distance here. So 3, I should write this out, I suppose. 3 minus 1 is, of course, 2. Oh, let's use blue. Right? BC is 2 units. And if I go AC, I get 5. Now, for those of you who are like, show me again. Hey, you can always count 1, 2, 3, 4, and 5. All right, I'm 6 minutes in. I only get 15 minutes, so I better speed up. Find inch length. Please try these problems right now. X to Y, so I get 1.5. Y is 5. 5 minus 1.5. 5 minus 1.5, of course, is 3.5. And XZ, ooh, now I've got a negative in there. I'm going to do negative 3 minus 1.5. So a negative minus means I'm going continued. So that would be negative 4.5. But length cannot be negative. Length is always positive, which is why we take the absolute value. The absolute value of negative 4.5, of course, is 4.5, 4.5 units, whatever those units are. Congruent segments, very important concept here. Please put it in your definition section. And note, are segments that have the same length. So congruent segments have the same length. In the diagram, you can see PQ equals RS. So the length is the same, therefore the segments are congruent. Note, this is the symbol for congruent, which means same shape, same measurement, etc. All right? We use tick marks. These little things are called tick marks to show that segments are congruent. Segment addition. In order for you to say that a point is between two other points, all 3 points must be on the same line. What do you call it when all 3 points are on the same line? Collinear. If I was more prepared, I would have put something like a magic word to open up. I'll do that next time. All right, so collinear. You can see here, AB. Now again, there's no little segment bar, but we're saying the length, because B is between A and C, the length from A to B plus the length from B to C equals the length of the entire thing. This will kind of jump out and be more obvious. Go ahead and try this problem here, and then I'll show you the solution in just a second. All right, very good. You're back. Let's draw a quick line here because it says G is between F and H. So draw a picture. When in doubt, draw a picture. Let's put some points on there. So I've got F, G, and H. Now, sometimes your drawing does not match the math or the numbers that go with it. Don't worry about it. This drawing does not say to scale. If it says to scale, then you have to trust the drawing. If it doesn't say to scale, then it's just to help get your brain around a problem. So it says FG is 6. Oh, great. They gave me that information. And they said FH is 11. Well, that means from here to here is 11. So how far is it from G to H? And of course, you would say 5. Is my drawing to scale? Absolutely not. G should be way over here. But it doesn't matter. The idea is I kind of know how things line up. It makes it much easier to solve the problem. All right, I'm going on 10 minutes here. I better get moving. Finally, try this problem. N is between N and O. Find no. All right, you've paused the video and you've tried this problem. So let's set it up. M is between N and O, which means 17. I will find a better way to do this. First, you need to set up the problem. NM, according to segment addition, plus MO, 3x minus 5. Oh, this is horrific. Equals NO, equals the whole thing. 5x plus 2. Hey, when I get my smartboard back, you know what I'll do is I'll have this problem projected, and I'll go walk over to the board, and then you can see me do it there, but it'll look much cleaner. Now I'm in algebra land, right? You guys have already taken algebra. Well, how are we going to solve? First thing we need to do, we need to solve for x. Let's get all the x's on one side. Hey, I'm going to change colors and make things easier for you guys. Let's subtract 3x from both sides. Now, if you haven't seen me do problems before, I like to just do everything all at once. I'm going to combine these terms. 17 minus 5 is 12. Let me do that a little bit different way. Okay. Let me just bring, and I'm also going to subtract 2 from both sides. Right? And I still have my equals in the middle. All right, so now I've got the 3x's cancel out on this side. Right? And I've got 17. And I've got, I should say 12. Sorry, guys. Just bear with me. I think you're better off in the math and just giving an example. So 12 minus 2, of course, is 10. So 10 equals 2x. Divide both sides by 2. Of course, you're already ahead of me. X equals 5. Now that I know what x is, I have to go back and substitute it in. It says find NO, so it's saying find the full length. Well, hey, the easiest way to do that is plug this 5 in here. I'm sure you like the sound effect. 5 times 5, substitute in, plus 2 equals 27. They don't give you units. It could be light years, it could be inches, it could be millimeters, it could be microns. So it doesn't tell you. Please put a final box around your answer. The answer is 27. 13 minutes. I got 2 minutes left. I'm going to try to speed it up here. Last but not least, midpoint of a segment. This is one of, I believe, your definitions. Splits or bisects the segment into 2 congruent segments. Now, this is really hard to read, but this says 3x minus 3. This is 15, right? I know that these two things have to be equal. So, right, if you wanted to figure out what x had to be, I'd add 3 to both sides. So let's do that. Add 3 to both sides. And I get 3x equals 18. Divide both sides by 3. I love algebra. I love the mechanics of it. And x equals 6. Right? The other thing you know right off the bat is if this side is 15, this side has got to be 15. All right, anything else? Don't worry about that. I'll show you that another time. We'll talk about that together. So again, today, this lesson talks about segments, midpoints, length, figuring those out. In class, we will take care of constructions using a compass. So look forward to that when you're in the classroom.